Welcome to this tutorial on deploying Phi-4 Mini using Microsoft Azure AI Foundry. Let's get started. First, navigate to the Microsoft Azure portal and sign in with your credentials. Once signed in, open Azure AI Foundry, go to Directory and select Go to Azure AI Foundry portal. At the top, click on Azure AI Foundry and the project that contains your endpoints and API keys. On the left panel, select Model Catalog, where you'll find models like Phi-4 Mini, Phi-4 Multimodal, and many more. Now let's check out Phi-4 Mini. Phi-4 Mini is a 3.8 billion parameter language model developed by Microsoft. It is optimized for math, coding, and reasoning tasks, performing at a level similar to models twice its size. This model supports multiple data types and various languages, making it highly versatile for AI tasks. Click on Deploy to view the deployment options. 1. Serverless API with Azure AI Content Safety. 2. Managed Compute without Azure AI Content Safety. For this, we'll select Serverless API with Azure AI Content Safety. In the Overview section, enter a deployment name and ensure content filtering is enabled. Finally, click Deploy and your model will be set up. While the deployment process takes some time, let's go through a quick summary of the research paper on Phi-4 Mini and Phi-4 Multimodal. Phi-4 Mini Technical Report: Compact yet powerful multimodal language models via mixture of LoRa's. 1. Introduction. The Phi-4 Mini and Phi-4 Multimodal models are designed to provide high performance in language and multimodal tasks, despite being relatively compact. Phi-4 Mini, a 3.8 billion parameter language model trained on high-quality datasets with a focus on math, coding, and reasoning. Phi-4 Multimodal extends the capabilities of Phi-4 Mini by integrating text, vision, and speech audio modalities, allowing it to handle diverse tasks like image and speech understanding. Key features: expanded vocabulary, 200K tokens for better multilingual support, group query attention for efficient long-sequence text generation, mixture of LoRa's approach to enable multimodal capabilities without fine-tuning the core language model. 2. Model architecture. 1. Phi-4 Mini language model uses a decoder-only transformer architecture with 32 layers and a hidden state size of 3072. Employs group query attention with 24 query heads and 8 key value heads, reducing memory usage for long context generation. Rope-based positional encoding ensures smooth processing of long text sequences. Trained on high-quality math and coding datasets to enhance problem-solving skills. Vision processing, and images passed through the SIGLIP 400M encoder. The vision projector maps the image features into a format the language model understands. The LoRa adapter fine-tunes vision-related tasks while keeping the core language model unchanged. Speech audio processing. Audio is converted into log-mel spectrograms. The audio encoder extracts meaningful features. The audio projector maps audio features into the text space. The LoRa adapter enables speech-related tasks, ASR, translation, summarization. 3. Training process. The training process consists of multiple stages. 1. Language training. Pre-training data, 5 trillion tokens, including curated math and coding datasets, filtered high-quality web data, synthetic reasoning data. Post-training, additional instruction tuning data to improve real-world usability. 2. Vision language training. Uses a SIGLIP 400M image encoder fine-tuned with large-scale image-text pairs. Includes OCR, diagram comprehension, and video understanding data. Implements a novel multi-crop strategy to process images of various resolutions efficiently. 3. Speech and audio training. Uses 80-dimensional log-mel spectrograms as audio features. Training includes automatic speech recognition, 2 hours of speech data, speech-to-text translation, 100-meter curated examples, speech summarization, long audio processing. The audio encoder uses 24 conformer blocks with 1024 attention dimensions. 4. Reasoning training. The reasoning-optimized Phi-4 Mini variant is trained on 60B synthetic reasoning tokens. It undergoes additional fine-tuning on chain-of-thought reasoning data to match the performance of much larger models. After successfully deploying Phi-4 Mini, click on the Open in Playground button. This will launch a chat session where you can interact with the model in real time. For example, if you ask the question, "What is life?" the model will instantly generate a response. Since Phi-4 Mini is a text-only model, it is designed for tasks involving math, coding, and reasoning. It uses Group Query Attention, GQA, to process queries efficiently and has 3.8 billion parameters for delivering high-quality responses. Now, we will deploy Phi-4 Multimodal. Phi-4 Multimodal is an AI model that supports text, vision, and speech audio processing. It extends Phi-4 Mini by adding multimodal capabilities while keeping the core language model unchanged. Click Deploy to view the available options. 1. Serverless API with Azure AI Content Safety. 2. Manage compute without Azure AI Content Safety. For this, we'll select Serverless API with Azure AI Content Safety. In the Overview section, enter a deployment name and ensure content filtering is enabled. Finally, click Deploy and your model will be set up. This Python script interacts with Azure AI's Phi-4 model, both for text-based and image-based queries. Loads environment variables from a .env file, which stores the API key and Azure endpoint URL securely. Sending a text query to Phi-4 Mini. What it does: sends a request to the Phi-4 Mini model with a text prompt. What is 5 square? The model responds with, the square of 5 is 25. This is because 5 multiplied by itself, 5 by 5, equals 25. Sending an image query to Phi-4 Multimodal 1. Converting an image to base64 format. What it does: converts an image file, Phi-4 multimodal.png, into base64 format. This base64 string is used to send image queries to the AI model. 2. Sending the image query to Phi-4 Multimodal. What it does: sends a multimodal query text image to Phi-4 Multimodal. The user asks, describe the image. The model responds, the chart presents gender distribution, service experience, case handling trends, and nationality data in a support team or aviation-related context. Left chart, gender distribution across different roles, yellow for males, blue for females. Top right donut chart, 2,782 total cases processed, with 1,373 cases handled by experienced members, 5+ years. Middle right chart, year-wise case handling growth from 2018 to 2021. Bottom right chart, nationality representation in the workforce or aviation sector. Now, let's continue summarizing the research paper by exploring the evaluation and performance of Phi-4 Mini and Phi-4 Multimodal. 4. Evaluation and performance. 1. Language performance. Phi-4 Mini achieves state-of-the-art results among models of similar size. Math and reasoning. Outperforms DeepSeek R1 Distill, QuensMB on GSM-8K, Math, and MGSM. Coding, strong results in human eval and MBPP benchmarks. General NLP, competitive on MMLU, ARC-C, Truthful QA, and Winogrand. 2. Multimodal performance. Phi-4 Multimodal performs exceptionally well across vision, speech, and audio tasks. Vision language, outperforms Qwen25VL, Intern VL25, and Gemini 2.0 Flash in OCR, Chart QA, and Science QA. Speech and audio, ranks number 1 on OpenASR leaderboard, surpassing Whisper V3 and Seamless M4T. Conclusion. Phi-4 Mini sets a new standard for compact language models, achieving high math, reasoning, and coding performance. Phi-4 Multimodal introduces efficient multimodal capabilities using LoRa's, making it highly adaptable. With state-of-the-art results across language, vision, and speech, these models demonstrate the potential of small yet powerful AI architectures. Thank you for tuning in. Let us know in the comments if there's a paper or topic you'd like us to explore next.